this is ULAS exercise 2. First, to plot the data. So these are the XY coordinates, so it's just these two columns. We've got on the x-axis we've got lead measured in ppm. These are measurement standards, and then calibration is according to the count, which is in the second highlighted column there. Go to insert. It's the XY scatter, and as it's a trend line we just place XY scatter with markers. Now to add the trend line, which will be linear, and going to more options, display the equation on chart, and you're also asked to display the R-square value. Now to label the axes and also give the chart a title. We've got axis titles here. On the y-axis we've got count. On the x-axis we've got lead concentration measured in ppm. Chart title, lead calibration curve. Now I note on the y-axis that the data runs mainly from 4000 to 5000, so I will format the minimum and maximum accordingly. I point at one of the numbers along the y-axis, right click, go to format axis, and I'm just going to display data from 4000 to 5000. Move the formula just a little. Now you're asked in the exercise to format the label for the equation of the line and to display the slope with 3 significant figures. To do that, I'll right click on the equation and go to Format Trendline Label. Then in number I will choose, which is simply the default, which is 2 decimal places, so that is done. So that pretty much covers the first part of the exercise. Now to use the equation of the line to calculate the expected count corresponding to the following values in ppm. In this case I am just calculating using the equation y equals mx plus c. Count of course is the y variable, so just type equals, it's the slope, in this case we're using 9.68, times the x measurement plus the intercept, which is 3996.34. And now I can auto fill down because the Excel function, wherever there's an address, it will track down along the same row numbers and just feed those other values in like so. These results are best presented as a whole number, so I shall adjust accordingly, and also to center the data. And that concludes ULAS exercise 2.